Hey guys, my topic today is testing of a new lubricant in cold metal forming. Now what is metal forming? Metal forming is basically shaping a metal in different sizes and shapes by different methods. Cold metal forming is basically metal forming at room temperature. It's an example of metal forming process by means of roller die. Now why is lubrication required in metal forming process? First and most important reason is to reduce friction and its impact, like addition, galling, scratching and material transfer. And second most important thing is to obtain a full workability of the workpiece. And in the current scenario, a lubricant requires to be eco-friendly and cost-effective. Now what are the problems with conventional lubricants? They're highly flammable, expensive and rigorous disposal, and at the same time, during the disposal, they release a huge amount of pollutants and sludges. And they have a high initial procuring cost. And they're not renewable and not eco-friendly in nature. Hence, what is the alternative proposed solution? Here basically boric acid, which is a laminar-based solid lubricant, is subject to various metal forming operations and tests and depicted in many journals. Now why boric acid? Boric acid under 170 degrees Celsius undergoes crystallization. In this process, or at this time, the van der Waals forces of attraction between each layer decreases and covalent bond between the atoms increases. As a result, when forces are applied, these layers have a tendency to slide over each other, thereby exhibiting lubrication properties. And most importantly of all, boric acid is easily available, it's non-renewable, eco-friendly and cost-effective in nature. Now let's analyze a few tests to derive the research question. Initially, boric acid in this experiment, it tested for various metal forming processes on different types of workpieces, along with other conventional lubricants and inclusive of a no lubrication condition. The result shows that boric acid does exhibit lubrication properties. The drawback of the experiment was that this experiment did not study the replenishing nature of boric acid. From the graph, it's pretty evident that during a deep drawing test, boric acid performed the best compared to the conventional lubricants. And in other experiments, it performed at a comparable level. The drawback of the previous experiment being that it did not undertake or study or evaluate the replenishing nature of boric acid. This test covers it up. In this test, a ball and disc experiment is conducted. The lubrication conditions used was boric acid and a mineral oil combination. This depicted the replenishing nature of boric acid. But drawback being that it did not analyze for other forming operations and at the same time, it did not mention which mineral oil was used. From the graphs, it's pretty evident that the combination of boric acid and mineral oil performed the best when compared to all the other conventional lubrication conditions. From the success of the previous experiment, a new combination was formulated, which is basically boric acid and canal oil mixture. This experiment is tested by means of a strip tensile tester, which is basically a form of a forming operation. This experiment resulted in the conclusion that this mixture of canal oil and boric acid does experience lubrication properties, which is basically stated in the graph. Here, graph plotted between the coefficient of friction and with respect to sliding distance. And here, transmission oil and canal oil and the boric acid were subjected. And it's evident that canal oil and boric acid performed better than the transmission oil. In test 4, a similar pin-on-disc experiment was performed. This experiment was performed for one main reason, to identify which mixture ratio performed the best in between boric acid and canal oil. From the experiment result, a 7% boric acid along with canal oil was mixed up. And this combination performed the best. But drawback of this experiment being that it did not take into consideration the combustible nature of this mixture. And at the same time, it wasn't compared to a wide variety of conventional lubricants. In the final test 5, this boric acid lubrication mixture was compared or was subject to a pin-on-disc experiment, not similar as before one. Here conditions used were different. It was similar to a brake valve specification. This was performed to test the effectiveness on a long run of this combination. Here, a wide variety of lubrications were used, namely transmission fluid, and one special condition of transmission fluid along with boric acid. From the graph, it's pretty evident that this mixture of canola oil and boric acid do not perform better than transmission fluid itself. And the performer, or the best performer of the experiment was actually transmission fluid with boric acid. The gap being that again, the combustion mixture was not taken into consideration, and it did not outperform this mixture of boric acid, canola oil, did not outperform transmission fluid. Hence, since we're deriving an eco-friendly lubricant, since the transmission fluid which is used here is not eco-friendly or not, neither is it renewable in nature. As a result, this drove to my research question: which biodegradable oil can be combined with boric acid to obtain an ideal eco-friendly lubricant? Hence, I propose a research design. This is basically an experimental design with a means of mixed quantitative and qualitative data collection method. In the first step, various information and data is collected in relation with all the mineral oils existing right now. And then they further analyze and test it. And then the second stage of testing consists of combining these mineral oils which are obtained previously to be combined with boric acid, and then this combination study is undertaken and tested. From this test and investigation, at least one or two combinations of boric acid and mineral oil is obtained theoretically. This combination is then further subjected to two main tests. The first test is basically a similar pin-on-test experiment to study its effectiveness as an effective lubricant and how it performs in the long run. Second experiment is basically subjecting it to various metal forming operations along with the conventional lubricants, comparing them together. This is basically to study if it's effective on a wide range of metal forming operations, and at the same time to see if it's better than the conventional lubricants which are used. And I hope so, at least theoretically, at least one combination of boric acid and mineral oil can be obtained, which does satisfy the condition of it being an ideal conventional lubricant. Thank you.